Have you ever wondered how your computer manages multiple tasks at once? How does it keep track of everything from browsing the web to playing games without getting confused or crashing? Enter the world of processes, individual programs running on your computer. Each process has its own dedicated space in memory to store data and instructions. The operating system, like a vigilant supervisor, manages these processes, ensuring they don't interfere with each other. So processes are like individual workers in a kitchen, each with their own task to complete. Now, what if our kitchen workers could do multiple tasks at once? Welcome to the world of threads. Threads are like smaller, sprightly versions of processes, capable of executing a sequence of instructions independently. Imagine them as miniaturized, nimble workers within a larger worker, each focused on a different task. Just like an orchestra of musicians playing different parts of a symphony, threads within the same process can share the same memory space. This shared environment allows them to easily communicate and collaborate, making the execution of tasks more efficient and synchronized. Drawing from our kitchen analogy, think of threads as mini-helpers assisting each worker or process on different parts of the same recipe simultaneously. They could be chopping vegetables, stirring the soup, and checking the oven, all under the umbrella of the same worker. This collaboration enables the quicker and more efficient completion of tasks. Think of threads as the mini-helpers in our kitchen, working together to efficiently complete a recipe. But who's managing all these processes and threads? That's the job of the kernel and its data structures. The kernel is like the beating heart of the operating system. It's the core component that juggles the computer's resources, ensuring every process and thread gets a fair share, while also facilitating seamless communication between the hardware and software. It's like a master conductor, orchestrating a symphony of processes and threads to deliver the performance you experience on your screen. But how does the kernel keep track of everything? Enter kernel data structures. Think of these as special containers or organizers that the operating system employs to keep a tab on all the processes, threads, and other crucial information. They're like the conductor's score, outlining what each part of the orchestra should be doing and when. For instance, there could be a data structure that holds information about all the currently running processes, another one for managing memory, and so forth. These aren't just ordinary containers, though. They're carefully designed and optimized to ensure the operating system runs as smoothly and efficiently as possible, kind of like how a top-tier head chef organizes their kitchen for maximum productivity. So, the kernel, with its data structures, is like the head chef in our kitchen, using special recipe books and ingredient lists to keep everything running smoothly.